Hello everyone, Assalamu alaikum. Today our topic is about the atom. Basically, in this world, everything is made up of material particles, which are called atoms. And atom is basically a basic building block of matter. But atom itself is basically made up of smaller and smaller particles. So that's why it is essential today. I want to discuss about that composition and what is the historical background of atom. So let us start our topic from the earlier Greek regime. So there are different views of different scientists about atoms. So before modern views, I want to discuss the earlier view about atom. So the earlier view about atom given by the Democritus. Democritus is basically a very famous Greek philosopher and who gave idea about atom about 25,000 years ago. He says that if we have a particular object and we cut that object in half and then half up half and after that again half up half, so we eventually approaches to a very smaller particle which is cannot be further cuttable, or in other words we can say that that particle cannot be indistinguishable or indivisible or indestructible. So that indestructible particle which cannot be further divided, we can call that particle atomos. He can call basically that particle atomos, and nowadays we call that indivisible particle atom. So in that earlier days he called that smaller particle atomos, which means uncuttable, indestructible or indivisible, and he says that everything in this universe is made up of atoms. Same thing made of same atoms, and different things are made of different things. So this is the view of Democritus. But in that days there is also another Greek famous philosopher who is more famous than Democritus, and his name is Aristotle. So Aristotle was very famous compared to the Democritus. Therefore, people gave more value to the idea of Aristotle compared to the Democritus. And what is about atom, the idea of the Aristotle? The Aristotle idea about the atom is this. Aristotle says that basically atom is made up of five basic things in this universe, and that five basic things are basically air, fire, earth, ether, and the fourth one thing is water. So these are basically the five things. According to Aristotle, everything in this universe is made up of these things. So this is according to him, this is the overview of about atom of Aristotle. No one challenged the idea of Aristotle in that days, and the main reason for that is the experimental evidence, because in that days there is no experimental evidence. No one can provide experimental evidence that whether the atom is this or like that. So therefore up to 2000 years no one can challenge their idea. After that, almost 2000 years after the Aristotle idea, in 1808, John Dalton is another famous scientist who proposed his own atomic theory about the atoms. He studied gases in those days and experimentally verified that what is atom. According to John Dalton, atom is basically an indivisible particle which cannot be further divided, so it is indestructible. So it means that he supports the idea of Democritus. He says that all matter is composed of atom. Atom can neither be created nor destroyed. and atoms of the same element are same and atoms of the different elements are different. When atoms are rearranged, chemical reaction takes place. This is the another postulate of the John Dalton, and he says that when different atoms of different elements are combined together, compounds are formed. After John Dalton in 1897, J. Thomson challenged the idea of John Dalton, and J. Thomson says that atom is further dividable. It is not indivisible. It is further dividable because of in their days he experimentally proved the electron discovery. He discovered electron through cathode ray tube, in which he connected a particular supply. He supply voltage between cathode and anode, and he observed that there are certain particles which are travel from cathode towards anode, as anode has a positive charge. Therefore, he concluded that only those particles will move towards positive anode that possesses opposite charge of anode, and he called that as a cathode ray R, which we nowadays call electron. So that's why he discovered electron, and after discovery of electron, he also called, nowadays this model is also called a plum pudding model. Why this model is called a plum pudding model? Because according to him, atom has a constant positive charge density, or atom has a uniform positive charge distributed throughout the atom, and in that positive uniform charge distribution, electrons are scattered throughout the positive charge. So just we can take example of that, like for example, this is the water tank, and in this water tank, let's suppose we drop some small rubber balls. So that rubber balls are like electrons, and that positive fluid which we call water is act like a positive charge. So that's the idea of the J. Thomson about the atom. But J. Thomson was also challenged by the Rutherford, and Rutherford said that atom has not uniform density, rather than it has a positive charge concentrated in the center of the atom, and electrons are revolved around the atom. So that's why this model is also called planetary model, and according to him, electrons are like a planets revolving around the earth. Or this model is also called nuclear model because he discovered nucleus in their days. How he discovered nucleus? He basically bombarded alpha particle on a gold foil, and he observed that most of the alpha particle go straight through gold foil, and only a few alpha particle rebounds are scattered with some other angles. So he concluded from that only particle can scatter from the target which possesses the same charge as that of the alpha particle, as he already know that alpha particle has a positive charge. So only positive charge can be scattered from a positive charge. So as we know that only from small region scattering occur, so he concluded that as the alpha particle goes straight in most region, so that's why according to Rutherford, most of the atom is empty and only a small region possesses charge, and he called that smaller region as a nucleus. So positive charge is concentrated in the center of the atom. Atom mostly has empty spaces because alpha particle passes straight through most of the region of atom, and only positive charge is concentrated in a small region, and he called that small region as a positive charge. After that, he also discovered proton, and some people think that it is discovered by the Goldstein, and in 1932 after that neutron are also discovered. So it means that now atom is further dividable. Atom possesses electrons, possesses positive charge, possesses neutrons. electrons revolve around the nucleus, while protons and neutrons are inside the nucleus. So after Rutherford, another famous scientist, Bohr, proposed its own model, and he challenged the model of the Rutherford because Rutherford model has its own drawbacks. Similarly, Thomson model has their own drawbacks, and John Dalton model also has some drawbacks. So therefore, Bohr proposed a semi-classical model because he included some modern view, and also he helped from some classical points and proposed another model that's called semi-classical model. According to this model, electron revolve around the nucleus in a particular discrete energy levels, and that discrete energy levels are basically called orbits. According to Bohr, when electrons are in a specific orbit, it cannot release or absorb energy. But when electron jumps from higher orbit to lower orbit, it releases energy. And when electron jump from lower to higher orbit, it basically absorbs energy. And this release or absorption of energy are only in a discrete form. Electron release or absorb energy only in a discrete packets form, which are called photons. So basically, when electron jump from higher to lower state, so it release photon having energy E2 minus E1. E2 is the higher energy state energy, higher state energy, and E1 is the lower state energy. Another postulate of his model is the angular momentum of electron revolve around the nucleus is always quantized, and it is equal to L is equal to R cross P, or MVR is equal to NH by 2 pi. So this model also has some drawbacks. After that, Debroglei gave his own view about the matter. He says that basically the nature of particle as well as the nature of wave is dual. Sometimes particle behave as a wave, and sometimes particle behave as a particle. Similarly, sometimes wave behave as a wave, and sometimes wave behave as a particle. And the wave nature of particle is experimentally verified by Davison, Germer, and J.P. Thomson. And J.P. Thomson is the son of basically J.J. Thomson. J.J. Thomson discovered particle, which is electron. So basically, he proved particle nature of electron, and his son J.P. Thomson proved the wave nature of electron. So particle behavior as a wave is experimentally verified by Davison, Germer, and J.P. Thomson, while the wave possesses particle nature, and the particle nature of the wave is experimentally verified by the Arthur Holly Compton from scattering of the photons, and Einstein photoelectric effect. We can observe the particle nature of the wave. After that, Heisenberg also gave support to the Debroglei, and Heisenberg explained that we cannot determine the position and momentum of a particle at the same time accurately, and the product of position and momentum of a electron is approximately equal to the Planck constant. After that, Erwin Schrodinger come in 1920 or round about 1926, and he proposed another beautiful model which is called electron cloud model. This model changed the overall view about the atom, because Erwin Schrodinger said that we cannot exactly say that electron lies in this point. We cannot say that electron is exactly lie at this point. He says that the electron position is always probable. Electron may be lie in this region, but we cannot say that exactly it lie in this position. So he says that electron revolving around the nucleus like a buzzing bee, and it behave like a wave. We cannot treat it as a particle. He developed a mathematical equation for the probability of the existence of electron, which is known as Schrodinger equation. So Schrodinger developed a mathematical equation for electron, that how we can find the probable position of electron. So this is the overall view about the atom. He also says that the electron position around the orbit is basically mostly possibility of electron around the nucleus is in orbitals. So that's why he gave the concept of orbitals. He developed a mathematical equation. He gave the concept of orbital, and the shape of these orbitals are different, which depends upon the location of electron, whether electron is in a s orbital, or it is in a p orbital, or it is in a d orbital. So s, p, d, e, f are different types of orbitals, and the position of electron may be somewhere there in their orbitals, and the shape of their orbitals are different. So I hope you people learn more about the atom. Inshallah, next time we explore matter more. Thank you.